Hello everyone, welcome back to LeetCode Daily Live where I do the daily question roll and uncut. So we have a medium today and more of these domino questions, and we have a Tromino as well, which I've never heard of, but it seems like it is a domino with three tiles. But yeah, um so we're actually only given an integer, which is only up to 1,000. So yeah, let's see what this question wants. So you have two types of tiles. So you have like the normal type and you have the L-shaped type with three tiles. So given an integer n, we want to return the number of ways to tile a 2 times n board. Since the answer may be very large, return it modulo, well, this big number. So in a tiling, every square must be covered by a tile. So I think it just means like you have to like cover like the whole 2 by n board. So, and also two tilings are different if there are two 4 directionally adjacent cells on the board, such that exactly one of the tilings has both squares occupied by a tile. What does that mean? So 4 directionally adjacent cells. Such that exactly one of the tilings has both squares occupied by a tile? We have to look at some example to see, I guess. So yeah, so you can do. Yeah, I think this is just like, I think it is a very wordy way of saying that yeah, I think like by looking at the example, well, you can see that rotation does not count as the same. So like you can have so like if you rotate this one 180 degrees, it will become this one, right? But they are deemed to be different. So that's the first thing. Also, like something like this, if you flip it around again, it will also be different. Oh, well, if you flip it around, they'll also be the same, but they are counted as two different ones. So, yeah. Yeah, I think like from my understanding, like by looking at the example, is that like from left to right, if we use different tiles, it will be counted as a different way to lay out the tiles, I think. So well, the first thing I thought of is definitely using dynamic programming. So, for example, if you have a, maybe I'll draw it out. Does DP even work here? I'm pretty sure kind of have, it kind of has to be DP, because like, so you have 2 by n and you have like some tiles that you have used already, right? And so you just want to like build on top of it, I guess. So like for example, if there are like n number of ways, maybe I'll draw a better version. Maybe something like this for now. So if there are n ways to form like whatever tiles you have on this side. I'm I'm doubting my DP right now. Yeah, need to think about this. This is not too obvious on how to do it, I guess. Yeah, but I think like the point is, maybe we look at the base case first. So if you're left with a 1 by 2 at the end, well, the only thing you can do is you only have one way here, right? Or if you're left with like a shape like this, then again you have one way, or like the other way as well, like this thing here. So that's our base case, which we can kind of like put it at the beginning as well as the base case. So at the beginning, we have like the 1x2 shape. We have this shape, and then we can also have this shape. I guess we can also have like the horizontal case as well. So is that exhaustive for all the cases? I would think so. So I think like for each of them, we want to find out the number of possibilities we can form, like because we have more tiles after this, right? If we can know the number of ways here, and then like more tiles here, if we know the number of ways to form here, and here, well, this one would be like there, and then there. So if we know the number of ways for all these 5 tiles, we can just add them up, and that will actually exhaust all the cases. So yeah, I think it will be DP. But the other thing is, I think we can actually combine these two, because if you use one of the like dominoes and you put it horizontally like this, well, you kind of have to put the next one down here, right? Like assuming that this is the bounce here, and like these 2 tiles below is not filled yet. So we can kind of like put them together at the beginning. So that means we will have 2 cases really. So the first case is like for the rest of the tiles, it forms a rectangle. So it will be the same for this case as well. The other case is that we have like one tile that's like loosed out here. So yeah, so we have one tile here, right? Like at the bottom, or we have one tile at the top, which I guess like if you rotate it, it'll be the same. But again, like remember, rotation are not counted as duplicates. So I think like we have to deal with these in different ways, I guess. But like we don't have to deal with cases like this, for example, because if we can gradually fill up like from the leftmost empty tile, we can kind of guarantee that like we'll either have this case, this case, or this case. So I guess like if we have the rectangle case, it will be the same as at the beginning, right? So like we have to think of this case, this, and so we have 4 cases. If it is an L shape, how many cases do we have? Well, the first one is filling it with this here. So a rectangle, a 2x1 rectangle, which would then make the remaining square look like this. And we also have the let's draw the L shape again. Yeah, I think like this question, you just have to like find out all the different cases, and then it shouldn't be too hard to code it up. I still haven't got like a very straightforward way to like indicate the one like tile here or something. Yeah, and then for this we can, well, obviously we can also use an L shape here, but that's actually the only 2 cases we have. So we just have to find the number of ways we can fill out the rest when we put this or when we put this. And the same thing for like when you rotate the box to fill in like this way. So I guess like with all these information, we can kind of start coding, but we might have to like go back to the drawing board a bit. So yeah, let's just start coding. Um, so we need a DP state. So I think for we don't need states. So I think like for each rectangle. So for each rectangle, uh, if we make the state, how many like, so you have a length here, right? Let's call this like m, and then this is obviously 2. So this is like the generic case, but then you can also have an add-on here. So like the whole shape would be like this thing here, or you can have an add-on here. So for each rectangle here, we kind of have 3 cases, I think. So we can make it so you just call it like -1. Maybe 0 is better. So for maybe 0, 0, 0 for something in range n. So that will go from, I guess we need n plus 1. Yeah. So what we can do here, yeah, I'm not sure if this is the nicest way, but I think like as we code, we'll get a better intuition on what's the nicest way to like code this thing up. So for base case, well, actually, where would the answer be? Well, if we store the answer at dp n, so if the first element represents how long this rectangle here is, then dpn 0. So 0 here would mean that we don't have any of these extra add-ons. I think like for 1 we'll go for the upper like add-on. For 2 we'll go for the lower add-on. So but this is where we can store the answer, I think. Yeah. So if that's the case, what is our base cases? Well, if we have a length 0 rectangle, well, obviously there is 0 ways. If we have one add-on along with a 0 with rectangle, well, we'll only have one tile each, right? But both of our tiles are either 2 or 3 big, so it'll be too big. So that means we actually don't have to deal with the 0 case here, because it will be the same here. And then for dp1, so that means we have one rectangle here. I think for all of them, so it'll be one rectangle, or we have like the add-ons. So actually it will be 1, 1, 1, because there are only one ways to fill them, really. So oops. You can do something like this, and we want to find this basically at the end. So how do we do that? I think we want to start from rectangles of size 2. So for width, in range, I think 2 all the way to n plus 1, because we do want to evaluate n here. Yeah, what can we do here? So So when we have a width 2 with no add-on, so we have the no add-on, and then we have the top add-on, and then we have the bottom add-on. So we have 3 cases to deal with. So if there are no add-on, remember we have 4 ways to fill that up. So that means dp to 0, dp with 0 is going to be equal to, so for the first case, if we fill with a 1x2 vertically, we have to find the number of ways for this rectangle here, right? So it will be dp with -1, 0. And then the next case, it will be actually like with -2 rectangle plus an add-on for like plus top or bottom add-on. So with -2, 0. Wait, is it? No, it's not 0. It's 1, because like that's the add-on, right? And then here we can do 2 here, and then we have the last case where we have like 2 horizontal, like 2 tile dominoes. So we just want to add this as well. So that's going to be our dp for no add-ons. And if there are add-on at the top, so for example, if width is 2, we will be looking at the we'll be looking at this case here. So what do we? So that means like we are looking at these stuff here. So if we fill the top, so yeah, we have 2 ways. If we fill the top with the L shape, we just have to move, like we just have to find with -1 without add-on. So it will be dp with -1 without add-on, or we can again we can do it with -1, but then we have the bottom add-on in this case. So with -1, and then we have the bottom add-on, which should be should be 2. So, and then I think for bottom add-on, it should pretty much be the same, except here we will have the top add-on. So like if you, I'll go back to a better color. So, oh yeah. So if you add this on, like for the bottom one, well, you have like this width here, like with an add-on here, right? So yeah, so I think that's all the cases we have, and then we can just return dpn 0 at the end, because that represents a 2x(n) tile. Oh, there's one more thing we have to do. We have to modulo all the cases, because as I have said there, it could be too large. So I think we just do mod for all of these. So mod and then here we can do mod as well. I think this should work, unless it doesn't. Oh, it doesn't. What has gone wrong? Let's print out dp and we will know, I guess. Okay, so we have 0, 0, 0, that's correct. And then we have 1, 1, 1 here. So this is n is equal to 3, right? And then we have 1, 2, 2. So is that correct? Wait, actually, this is wrong, I think. Because there are 2 ways. Oh, I guess like for the 0 thing, do we want to set this as 1, maybe? Because like here, I think it only counted the vertical 2 by 1. So this is like a width 2 rectangle. It only counted the vertical case, but like for the horizontal case, like technically, it it is one way of doing it, right? So yeah, I think like that should be set as 1, but these ones should be set as 0 because they're impossible. So should I set these as 1? Yeah, I think that will still work because yes, you do have one way of doing that. Okay. I'll say there's a 70% chance it works, and it does. Nice. So yeah. So let's talk a bit about how I come up with the solution, I guess. Um. Well, I think like whenever you see a like a really large modular thing, it more or less correspond with DP, but also like the other thing is it makes sense that like if you so like if you're doing this in a brute force way, how would you do it? Well, you basically do backtracking, right? So you put like I say a 2 by 1 here, and then you try you try a 2 by 1 here, and then like you have a bunch of 2 by 1. So let's say like we have a with 3 kind of case. So we have a bunch of 2 by 1s, and then so that's one case because like we reach the end and everything is filled. So after that, you're gonna remove like that piece, and then you try other pieces, but none of them work. So you have exhausted all the cases for this kind of formation. You remove this, and then like you try the next one. That doesn't work as well. That doesn't work as well. And so on. And if you do backtracking, it will be 2 to the power of n time complexity, but we can use an idea, like we can use a cache to kind of make the time complexity from like 2 to the power of n all the way to on in our case, because like what we have done is maybe this is not the best example. Maybe I'll do a longer. Alright, let's say we have like n equals 5 or something. So when we have tried this case, we will have found all the combinations that can form the 2 by 2 rectangle here, right? So I think there will be number of ways will be 2. So number of ways is 2. Well, when we are checking for this formation now, we no longer have to check all the combinations here again, because we have found out for this shape here how many ways we can fill all the tiles. So like for this case, like we can just like return 2 here. So like by using this kind of logic and basically like storing for all the possible shapes in in constant time, because like we only have to look at a few cases for each of them, right? We can like achieve O n time. So I guess that's kind of how I get the intuition for this question, and also a lot of drawing. I think drawing helps a lot as well. So yeah, thanks for watching, and I'll see you tomorrow. Bye.